Hello! In today's lesson, we will solve examples in which we write a fractional number as an infinite decimal periodic fraction. Let's write down our examples. Our first example. The fraction is 2/3. In order to write this fraction as a decimal fraction, we have to divide the number 2 by the number 3. If we've seen this fraction in the examples, we've done the action, treating the fraction as a fractional number, but in the last lesson we were introduced to the new decimal fractional numbers, which are called periodic decimal fractional numbers, and we learned how to write these numbers down. But today we are going to write down exactly the fractional number as an infinite decimal periodic fraction. In order to do this, we've talked about how the fraction line represents the division sign. So I'm going to write down 2 divided by 3. 2, we divide by 3. We can't divide 2 by 3, so we write 0. 0 times 3 is 0. 2 minus 0 is 2. Next, we don't have any digits written down that we can omit for division. So therefore, we put a decimal point, add a 0, and divide 20 by 3. We need to take 6 each. 6 times 3 is 18. 20 minus 18 is 2. That leaves a remainder of 2. Then we add another 0. 20 we divide by 3, and again we multiply 6 by 3. And the result is 18. And once again the remainder is 2. 2. Let's add one more 0. 20 divided by 3. And once again, multiply by 6. 6 times 3 is 18. And again we have 2. So we see that this division will be infinite. There will still be some number in the remainder. So the result of the division is the following number. 0 integers. And the number 6, what will be repeated an infinite number of times. So in math, if the digit after the decimal point is repeated an infinite number of times, then we call such a fraction an infinite periodic fraction. And then this fraction can be written in a different form. We will write the repeating digit as a period. And in math we write 0 whole and 6 parentheses. Thus we say that the number 6 repeats, or the number 6 is in a period. There is another notation of this number. We can write 0 integers, and above the 6, above the digit that repeats, after the decimal point put a period. Or there's another way of writing 0 whole, 6 in a period, and then above the 6 we substitute a sign like this, but most often in math. In periodic decimal fractions, we can write them using brackets. Another example, if the minus sign appears in a fractional number, it doesn't affect the algorithm for writing a decimal fractional number. For example, if I have a fractional number minus 2/3, the algorithm for dividing 2 by 3 doesn't change. The fractional number is preceded by a minus sign. The result is a number minus 0.6 in the period. Now let's look at another example in which we write a fractional number as a decimal periodic fraction. Let's write down the next example, minus 7.9. Applying our algorithm, we'll write down minus and dividing of the number 7 by the number 9, while we write it in parentheses. In order to keep the minus out of our way, we're going to do the division in columns. 7 divided by 9. We can't divide 7 by 9, so we're going to take 0. 0 times by 9, that's 0. 7 minus 0 is 7. Put a decimal point and add a 0. 70 divided by 9, we need to take 7 each. 7 times 9 is 63. Or 70 minus 63 for a remainder of 7. The division is not complete. We add another 0, and again we divide 70 by 9. I end up taking 7 again, because 7 times 9 is 63. And you have already seen that when dividing we will have a remainder every time. And this remainder is equal to 7. If I add one more 0, I will have one more 7 as a result. Then I can write down the answer. 0.7 in the period. Of course, when we write a fractional number as an infinite period decimal, we don't always have the decimal part. The first digit after the decimal point is in the period. And we will face these examples in the next lesson. And for today, our lesson has come to an end. Goodbye. See you again.